So, we are looking at sequential testing. So, we looked at an example of a counter. So, it was a 3-bit counter, okay, reset, clock, right, and then these are the states. This is a count. When you reset, the counter goes to the all 0 state, and if you keep incrementing by clocking, it goes through all the 8 states. Okay, so, starting from 0 0 0 to 0 0 1 and all the way up to 1 1 1. Then it goes back to state 0 0 0. So, we implemented this using an incrementer, right, and we had a state register. The state register is a parallel in, parallel out register. It requires a clock, it requires a reset. Then the output of the state register is given as an input to the incrementer, and the output of the incrementer goes back as the input to the state register. So, we call this as x and y. So, y is the sum of x and the value 1, and the y value is loaded into the state register. So, initially when the reset is made high, okay, initially when the reset is made high, the register sets to all zeros. Then the reset is made low, then we start applying clock pulses. Okay. So, every time the clock goes to a high, the state register will load the value from the incrementer. The incrementer has produced the value 0 0 1 somewhere here. So, there is some time for the incrementer to go ahead and increment. Then similarly, from here to here the incrementer has time for taking 0 0 1 to 0 1 0. So, when this clock pulse comes in, it loads the new state and so on. Now, what may be the faults, single stuck at fault model? So, these are some of the faults that may be present there, right. In the incrementer, something could be stuck at 0, right. Our incrementer was like this. We had several half adders. So, we had half adders, See, I may have mentioned to you earlier that these are called tie cells. Okay, this we are tying the input to 1. Okay. So, this is called as a tie cell, and we are permanently connecting it to 1. So, if any is stuck at one fault on this, we will not be able to figure it out. Okay. So, if there is a stuck at one fault here, in order to activate the fault, we have to make it 0, but we can't make it 0, right? It is already connected to 1. You may also wonder, if there is a stuck at one fault, does it really matter, because it is anyway supposed to be 1, right. So, a stuck at one fault on this wire cannot be found, cannot detect stuck at one fault. Okay. Now, inside the half adder we have an XOR gate and an AND gate. So, I could have some faults there, right. It looks like this. So, this is my half adder, sum and carry. So, it is possible that this wire is stuck at 0 or stuck at 1, it is possible that this is stuck at 0 or stuck at 1, etc., etc. Okay. So, if you rewrite this, so let us call this as A and B, then this is A1 and this is A2, this is B1 and B2. So, our theorem tells us, it is called as the checkpoint theorem, by the way, I may have not named it before. So, the checkpoint theorem says that it is enough to test for stuck at faults on the primary inputs and the fan out branches. So, we have A stuck at 0, A stuck at 1, B stuck at 0, B stuck at 1, A1 stuck at 0, A1 stuck at 1, A2 stuck at 0, A2 stuck at 1. In the case of a half adder, see, there are only 4 possible inputs. Okay. So, we will see what are the inputs that we need to apply. Do we apply all 4, or is it enough to apply a fewer number of those, right. So, as before, we can see the stuck at 0 fault here we can eliminate, because one of them is enough. Okay. So, like this, a few more optimizations may be possible. So, let us try applying the test 1 let us try a different method, let us see whether it, because after all this is not such a big circuit. So, 1 let us try. So, that is supposed to give me a 1 here and a 0 here, right. So, what are the circumstances under which this 1 is likely to change? Okay. Which one of these faults will cause a 1 on this line to become 0? I suppose B1 stuck at 0 will B1 stuck at 0, I have forgotten that. So, B1 stuck at 0 will be caught, because if B1 is stuck at 0, output will change. Similarly, I think this is A1. Okay. Similarly, B stuck at 0 will be caught, right. A stuck at 0 will be caught, and then anything else. A1 stuck at 0 is also caught, but we have already eliminated that. So, it catches 4 faults. Right. Similarly, what are the circumstances under which 0 will change to 1? Okay. Those will also be caught. So, for example, if A2 is stuck at 1, it will get caught. A2 stuck at 1 will be caught, because the output will change to 1 here. If B2 stuck at 1, that will also be caught. If B is stuck at 1, that will get caught, right. So, if B is stuck at 1, B2 will also propagate that, and then anything else. If A is stuck at 1, it will get caught. If A is stuck at 1, it will get caught. I do not think anything else is caught, right. So, these are the, so you can see that 1 1 was a very powerful test vector. It caught quite a few tests, it caught quite a few faults. We are now left with only A1 stuck at 1, that is this guy. So, we will have to apply a 0 here. Okay. So, 1 1 is a very good test vector that we found. Now, we will apply maybe 0 1. So, that will cause the output here to become 0, and here it will become so, once again, what will cause the output from to change from 0 to 1? One is if A1 is stuck at 1, see I am getting a 1 here, and if that A1 is stuck at 1, it will get caught. All the others are already caught. So, we really can't, we do not want to go into the others. A2 stuck at 0, will it be caught? No, because A is already 0 now. So, that will not get caught. B2 0, that might get caught, because if B2 gets stuck at 0, this output will change to 0. So, as a result B2 stuck at 0 will get caught. B1 stuck at 1 will not get caught. Okay. So, 0 1 is a good test vector, it caught a couple of others. Now, we try A1 and B0, that will cause the same output. A2 0 will get caught by 0 1, because A2 is here. Currently, it is producing a 1 here. If A2 gets stuck at 0, 0 and 0 will produce a 0. So, this will get caught, and B1 1 will also get caught, I think, right. So, it will produce a 1 here. Okay. So, that is about all, right. So, we need, unfortunately, we still need 3 vectors, we could not do better than that. So, 1 1 0 1 and 1 0 are required to be applied.